This video is a quick overview just to highlight the most important parts that you will learn here in Chapter 8. As always, look for the videos that are at the very beginning of each section. I'm going to skip ahead to that page. Nope, maybe it's the next page. Here we go. As you see these videos here, they give you a good overview, a little bit more detail as well of the overview of the section. And do that at a minimum. But if you see that you have some questions about examples that are in the text, watch those videos as a reference too. So I'm going to go ahead and look at this idea of linear versus exponential growth. And this very first figure here, we have these two different types of growing patterns. The linear looks like a line, that blue line there, and the exponential is this kind of pink curve here that's showing a doubling effect. The definition for these are in the next page, where it says linear growth is a quantity that grows by the same absolute amount in each unit of time. In other words, think of it as you're adding the same value if the unit of time is a month, for instance. So you're adding the same value each month. But exponential growth grows by the same relative amount in each unit of time. Specifically here, we're talking about a percentage. So in that case, this comes into play more like when you're in say a savings account and you have a 5% growth every month. Okay, that's probably actually kind of high for a savings account. But you do have those definitions there and lots of examples that you can explore in this section about the differences and similarities between the two. The next section, and actually the last section that we will do in this particular chapter, is more on exponential growth and decay. And there's lots of formulas here. So I just want to point them out that we have calculations with doubling time here on page 500. On page 501, we have an approximate doubling time formula, or otherwise known as the rule of 70. Then we have a half time, calculations with half time, on page 503. And on page 504, we have the approximate half-time formula. Okay, so just watch for the wording in the question. If you can do an approximation, if it says approximately how much, then go for the approximate formula. But if you need a little bit more precision, on page 505, we see the exact half-life formula. And on page, or maybe I think it was on the bottom part of page 504, we see the exact doubling time formula. Now you'll notice that both of these formulas use this notation log. That is actually a function, kind of like you would think of addition or subtraction as a function or an operation. So you will learn more about logarithms here on page 506. And logarithms really tell us what is the exponent. That's what they're saying. A log is an exponent. Explore this brief review of logarithms. If you've got some questions, though, please reach out, because I know that for some that might be a little new or rusty. And then, as always, I want to point out on page 530 is the summary for the chapter, where you can locate these formulas a little quicker if you need them. Remember, we're just doing sections 8A and 8B in this chapter. Also, don't forget, if you've got questions as you're going through the problems in this chapter, click Ask My Instructor, and I am more than happy to help.